It starts with the last topic, that is conditional expectation and conditional variance, right? Conditional expectation and conditional variance. So here, first we starts with the conditional expectation. Later we go for conditional variance, right? So here we starts with conditional expectation. Then we go for conditional variance, right? So here conditional expectation is expected value of a random variable y or any random variable given that another variable x is known, right? Say for example, we'll consider the formula, that is nothing but conditional expectation of x given y. It means that conditional expectation of x given y is nothing but expectation of x only whenever y is known, right? So this is given by summation x running from 0 to infinity x into f of x given y, right? If x is a x and y are discrete case, we have one more formula, that is expected value of y given x. This is also summation y running from 0 to infinity y into f of y given x, where this f of y given x or f of x given y are nothing but the conditional distributions or conditional probabilities, right? We have same case with continuous x given y, I mean expected value of x given y, integration minus infinity to infinity x into f of x given y dx. Next, expectation of y given x, which is integration minus infinity to infinity y into f of y given x dy, right? So these are the four formulae to find out conditional expectation. Right. So these are the four formulae to find out conditional expectation, right? So next, similarly, we have conditional variance, right? So conditional variance is nothing but variance of x given y is nothing but expected value of x square given y minus expected value of x given y whole square. We have another formula, variance of y given x is equal to expected value of x square, sorry, y square given x minus expected value of y given x whole square, right? So these are the two formulae to find out conditional variance, right? So in which situation we are using this conditional expectation, right? That is nothing but what some of the real life examples here, right? Right. So if we know the customer type, right? If we know the customer type, right? So there may be a new customer or there may be a repeated customer, right? So here as x, then we can estimate, their expected purchase amount or expected purchase cost as y, their expected cost or expected purchase cost as y, by calculating expected value of y given x, right? Why y given x, where x is type of the customer and y will be the amount, right? So expected purchase amount whenever, I mean, if x is a new customer or if x is a repeated customer, depending upon it varies, right? So wherever you are applying or wherever you are identifying the expectation with the help of known information of unknown variable, there we can make use of conditional expectation by finding or by using any one of this formula. Clear? So now we go for some solved examples. Example number 1. Let x and y are discrete random variables with joint probability mass function with joint probability. Just a bit, somebody wants to join. With joint probability mass function f of x comma y is equal to x plus y divided by 21 for all x equal to 1 comma 2 comma 3 and y equal to 1 comma 2. Next, what is the conditional mean is nothing but conditional expectation of x given y equal to y, right? So here we are going to find out conditional expectation, right? So in that, the type of the case is it is discrete random variable, right? So whenever we have discrete random variable, we can use these two formula. I mean, any one of this formula. Now we go for solution. That is how to find out the conditional expectation, right? Answer, right? So though here the given distribution, see, x and y are discrete random variable with joint probability mass function. There is no full stop or there is no comma up to here, right? So you need to read up to here at a once. So let x and y are discrete random variables with joint probability mass function f of xy, x plus y divided by 21 for all x equal to 1 to 3 and y equal to 1 2. That is nothing but they given f of x comma y, that is x plus y divided by 21 for all x equal to 1 comma 2 comma 3 and y equal to 1 comma 2. Then what they are asking, very simple, they want conditional expectation of x given y. They want conditional expectation of x given y, right? Our aim is to find out this value. We know that, what do we know? Conditional expectation formula, right? So this is nothing but summation x into f of x given y, right? So here x running from 1 to 3 means here x equal to 1 to 3. Clear? Then what about this f of xy? Sorry, f of x given y. This is nothing but conditional. This is nothing but what? What? Conditional distribution of x given y. Right? So this is what? Conditional distribution of x given y. So then how to find out conditional distribution? We know that our joint probability mass function or joint probability density function, if divided by its marginal, then it gives conditional, right? So here what? f of y equal to marginal distribution of y. So our target is to first find this marginal distribution of y, then divided this joint probability mass function by marginal, then we get conditional. Then you take that conditional value here and run the x equal to 1, 2, 3, then you will get x expected value of x given y. Clear? So first, f of y is nothing but summation of f of xy, because it is a discrete case, right? They only mentioned it is a discrete case, so that's why it is summation. And we required marginal distribution of y, so take range on x. This is equal to summation x running from 1 to 3. 1 to 3, f of x is x plus y divided by 21, right? Okay, now f of y equal to, put x equal to 1, that is 1 plus y by 21. Put x equal to 2, that is 2 plus y by 21. Put x equal to 3, 21. That is 1 plus y plus 2 plus y plus 3 plus y divided by 21. So f of y is equal to 1 plus 2, 3, 3 plus 3, 6 plus 3y divided by 21. Suppose we take 3 common, that is y plus 2 divided by 21. This is nothing but y plus 2 divided by 7, right? Y plus 2 divided by 7. This is what marginal distribution of y. Now we are going to find out conditional. Now we are going to find out conditional x given y. This is equal to f of x comma y divided by f of y. So this is equal to f of x comma y is x plus y divided by 21 whole divided by, that is y plus 2 by 7. This is equal to x plus y divided by 21 into 7 divided by y plus 2. This is equal to 7 ones are 7 threes are. So now what we have, x plus y divided by 3 into y plus 2, right? So this is what our f of x given y. But what we need? We need expected value of x given y. This is nothing but x equal to 1 to 3 x into f of x given y, right? So expected value of x given y is equal to, put x equal to 1, that is 1. Otherwise we'll take first. Okay, now just a bit. That is summation x equal to 1 to 3 x as it is f of x given y. This is nothing but this one, right? So this is what f of x given y. This is x plus y divided by 3 into y plus 2, right? Again, who wants to join? You should join it early only whenever the time is given, right? Okay, right? So this is nothing but expected value of x given y. Now, here 1 by 3 is a real constant, so I will take outside. Next, the remaining things are, I will write same, x equal to 1, 2, 3, x into x plus y divided by y plus 2, because this 1 by 3 is outside the outside the summation. Now, this is equal to 1 by 3, right? And y y plus 2 is also independent of this variable, so I will take outside. That is y plus 2. So now summation I running from, this is common, 1 to 3, then remaining things are x into x plus y. This is equal to 1 divided by 3 into y plus 2. When you multiply first we need to multiply x equal to 1 to 3, x into x, that is x square plus xy. 1 by 3 y plus 2. So summation x square x equal to 1 to 3 plus y into summation x equal to 1 to 3 x. Why? Because y is the independent of this variable. So 1 divided by 3 y plus 2. Now x running from 1 to 3. It is nothing but 1 square plus 2 square 3 square plus y into x running from 1 to 3. 1 plus 2 plus 3. So this is 1 divided by 3 into y plus 2. 1 square is 1, 2 square is 4, 3 square is 9. 9 plus 4 plus 1, that is 14, right? That is 14. Here 1 plus 2, 3, 3 plus 3, 6. So it is 6y, right? So our answer is, final answer is 14. Okay, I will take 2 common here. Suppose here 14 and 6, suppose I took 2 common. 2 into 7 plus 3y divided by 3 into y plus 2, right? So this is what our expected value of x given y. Clear? And as y value changes, it will take the different expectations, right? If you have any doubt, you can ask. Otherwise, I will move to the second example. And now we go for second example. Let x and y have joint density function. Joint density function f of x comma y equal to x plus y for 0 less than x comma y less than 1. What is conditional mean? What is conditional mean? That is expected value of y given x, which is equal to 1 by 3, right? So we need to find out y given x at x equal to 1 by 3, and they given continuous case, right? So they only mentioned here let x and y are joint. I mean, let x and y have the joint density function, right? Okay, to find out this expected value of y given x, we need to find out what is the formula here. Just we need to write down the first formula. Integration minus infinity to infinity y into f of y given x dy. This is the formula to find out the conditional expectation. But what about this f of y given x? This is f of x comma y divided by f of x, right? So f of x means what? This is what marginal distribution of x. So this is nothing but integration over range space of y f of x comma y dy, which is equal to, right? Which is equal to, what is the range of y? The range of y is y less than 1 and x is greater than 0. So that's why y range is 0 to 1. F of x comma y is x plus y. With respect to dy, we need to integrate. So here, this is equal to integration 0 to 1 x dy plus integration 0 to 1 y dy. X is independent, so we'll take outside the integration sign. So here y means 0 to 1 plus y square by 2, 0 to 1. This is equal to x plus 1 by 2, right? So this is what our f of x. F of x, what we have? X plus 1 by 2. Now, f of x is given. Okay, now we go for f of y given x. This is nothing but f of x comma y, that is x plus y divided by f of x, that is x plus 1 by 2. Right. So now expected value of y given x. This is nothing but integration of y. Y f of y given x dy, but the range is about y only. Y is less than 1 and x is greater than 0. So 0 to 1, which is equal to 0 to 1, sorry, y into f of y given x. F of y given x is x plus y divided by x plus 1 by 2 dy. Right. So this is what integration. But what are they given? They given x equal to 1 by 3. So now you put just x equal to 1 by 3. This is nothing but expectation of. Now we are going to find out expectation of y if x equal to 1 by 3. Right. So this is nothing but integration 0 to 1 y. Here x is 1 by 3. 1 by 3 plus y divided by 1 by 3 plus 1 by 2 dy. So this is nothing but integration 0 to 1 y 1 by 3 plus y. This is nothing but what? 1 by 3 plus 1 by 2, that will be 5 by 6. Here obviously dy we have, which is equal to it is 1 divided by 5 by 6. So it is 6 by 5. Right. Now integration 0 to 1. So here when you multiply y inside, this will be y into 1 by 3, that is y by 3, plus y into y, that is y square dy. Right. So here 6 by 5 integration 0 to 1 y by 3 dy plus integration 0 to 1 y square dy. Right. So now it is equal to 6 by 5 outside as it is. Next here 1 by 3 integration 0 to 1 y dy plus integration 0 to 1 y square dy. So 6 by 5 1 by 3 y square by 2 0 to 1 plus y cube by 3 0 to 1. 6 by 5, this is 1 by 6 y square 0 to 1 plus 1 by 3 y cube, it is already 0 to 1. So 6 by 5 1 by 6 1 square minus 0 square plus 1 by 3 1 cube minus 0 cube. 6 by 5, it is 1 by 6 plus 1 by 3. Right. So this is equal to 6 by 5 1 by 6 plus 1 by 3, that will be 9 by 18, or 6 by 5 into 1 by 2. 1 by 2, right? This is equal to what? 6 divided by 10, or 3 by 5. Clear? If you have any doubt, you can ask. So I hope there is no doubt. Now let's move to the last example. Example number 3. Let x and y are continuous random variables with joint probability density function with joint probability density function f of x comma y equal to e power minus y for all 0 less than x, 0 less than y, less than infinity. Next. What is conditional variance? What is conditional variance of y given x equal to x? Right? So what is conditional variance? So here what they required, they want conditional variance for this time. Now we'll go for solution of this. So answer, what they want? Variance, right? So conditional variance, especially conditional variance of y given x equal to x they want. So this is nothing but expected value of y square given x minus expected value of y given x whole square, right? Then what we require just to analyze this formula to find out this value, we required expected value of y given x as well as expected value of y square given x. Then, so here to find out expected value of y given x, what formula says? Our formula says integration minus infinity to infinity. Here first term is y, so y f of y given x dy, right? Next we require this formula. So I mean that value, not formula. So that value can be obtained like this: integration minus infinity to infinity y square f of y given x dy, right? Okay, now to find out this, what we required? F of y given x equal to f of x comma y divided by f of x, right? Here also same. Next, to find out this f of x is nothing but integration f of x comma y dy. Suppose I want x, take another variable integration. For continuous, for discrete, take summation over the range space of y. Is it clear? So to find out this value, we need to calculate all these values. Clear? Okay, we start it one by one. Next, to find out first one, f of x equal to integration, right? F of x comma y dy over the range space of y, right? Next, f of x equal to integration. F of y is e power minus y dy. But what about range? Just to go back to this given example, range of y is x less than y less than infinity. So we take the same x to infinity, right? Okay, now which is equal to e power minus y divided by minus 1. The integration, see here, integration of e power x is e power x, but integration of e power minus x is e power minus x divided by coefficient of x. Say for example, integration of minus 2x dx is equal to e power minus 2x divided by minus 2. in generally integration of e power minus nx dx equal to e power minus nx divided by minus n, right? So in this way, we need to integrate, right? Now, over the limits x to infinity, over the limits x to infinity, right? So now, okay, limits f of x equal to minus 1 outside e power minus infinity minus e power minus x. When you multiply minus inside, it will be e power minus x minus e power minus infinity. We know that e power infinity equal to infinity and e power minus infinity equal to 0 always. So f of x equal to e power minus x minus 0. Hence it is e power minus x. Right? This is what we found f of x. Now we required f of y given x. This is nothing but f of x comma y divided by f of x. So f of y given x equal to f of x comma y is e power minus y divided by this will be e power minus x, right? So this is equal to e power minus x plus x, right? How means if you have any doubt, just check here. E power minus x, here 1 by e power minus x, so it will be e power x. So bases are same, power must be added. So e power minus x plus x. Expected, sorry, f of y given x equal to e power. I will take minus common, minus of y minus x, y minus x, right? So this is what our f of y given x. Now, expected value of y given x, our target is to achieve this value. So integration minus infinity to infinity y e power minus of x minus, sorry, y minus x dy. So this is expected value of x, sorry, expected value of y given x equal to integration 0 to infinity. Why it is 0 to infinity means, see here. If you forgot this, range of y will be 0 to infinity. Lower limit of y is 0, upper limit of y is infinity. So 0 to infinity y into e power minus times of y minus x dy. Clear? So now here to solve this integration, there is some difficulty. For that, put z equal to y minus x. Now our expected value of y given x will turn into integration 0 to infinity as it is. We'll never change this. So here y is there. What is y? We consider here. So from this z plus x equal to y. So here z plus x. Next e power minus it is z dz, right? Okay, now we'll take like this expected value of y given x integration 0 to infinity z into e power minus z dz plus integration 0 to infinity x into e power minus z dz, right? So which is equal to, I explained about this formula in a class. That formula is integration 0 to infinity e power minus at t power n minus 1 dt equal to gamma n divided by a power n. Just to compare 0 to infinity, yes, 0 to infinity. Instead of t, we have z, right? So z power 1 is there, right? So n minus 1 equal to 1. It means that n equal to 2, right? So this is equal to gamma 2 divided by a. Instead of e power minus, instead of t, we have z. So a is 1. So 1 power 2. plus x is outside, right? X is outside. So now what we have here? 0 to infinity, only e power minus z dz. So gamma 2 divided by 1 power 2 plus x into, same again compare is integration 0 to infinity, e power minus at. So instead of a we have again a equal to 1, but into z power it should be n minus 1, but here n equal to 1, right? Can I write that z equal to 1 minus 1, because z power 0 is nothing but 1. So here nothing means 1 here, right? So here n equal to 1. So that's why it is gamma 1 divided by 1 power 1. Clear? Then we know that gamma n equal to n minus 1 factorial. So gamma 2 is there, 2 minus 1 factorial. 2 minus 1 factorial divided by 1 plus x into gamma 1 is 1 always. Gamma 1, 1 always, right? So this is also 1 by 1. This is nothing but 2 plus, sorry, not 2 here. 2 minus 1 means 1 only. 1 factorial 1 plus x. What is this? This is what expected value of y given x. Expected value of y given x is 1 plus x. Right? Now, here, what we required? We found this, but we need to find out expected value of y square given x also. For that, expected value of y square given x, expected value of y square given x is equal to integration minus infinity to infinity y square f of y given x dy, right? Okay, now integration minus infinity to infinity y square as it is, this is obtained, that is e power minus of y minus x dy, right? Same again, put z equal to y minus x, then expected value of y square given x equal to 0 to infinity, this is y square, y means z plus x whole square e power minus z dz, right? So next, equal to integration 0 to infinity. First we'll split a plus b whole square. So a square means z square, b square plus 2ab into e power minus z dz. 0 to infinity. So this is z square e power minus z dz plus x square 0 to infinity e power minus z dz. Why? Because x is independent of z, so I'll take outside, plus 2x integration 0 to infinity z e power minus z dz, right? Which is equal to, again you compare with that formula. So what will get here? You will get n equal to 3 here, right? Gamma n means 3. A is 1, that is 1 power 3 plus x square gamma 1 by 1 power 1 plus 2x gamma 2. Why it is gamma 2 means here a value is 1, so 1 power 2. This is gamma 3 plus x square gamma 1 plus 2x gamma 2. This is 2 factorial plus x square 2x into 2, sorry, it is not 1 factorial, yeah, 2 minus 1. 2 factorial value 2, x square value is x square plus 1 factorial is 1, so it is 2x, right? Is it clear? This is what expected value of y square given x, it is equal to x square plus 2x plus 2 we got. Right. So now we are going to find out variance. Right. So variance of, sorry, not y square, variance of y given x it is. Variance of y given x equal to expected value of y square given x minus expected value of y given x whole square, which is equal to expected value of x square given x is x square, sorry, y square given x is x square plus 2x plus 2 minus, here we have 1 plus x, but it's whole square, right? So this is equal to x square plus 2x minus 2, sorry, plus 2 minus 1 square plus x square plus 2x, because it is a plus b whole square. So x square plus 2x plus 2 minus 1 square is 1 minus x square minus 2x plus x square get cancelled, plus 2x minus 2x get cancelled, 2 minus 1, the answer is 1, right? So here the variance of y given x is 1. So I hope this example is clear.